Okay, hello and welcome everyone to the March 2025 edition of the DFINITY Global R&D meeting live from DFINITY headquarters here in Zurich. My name is Björn. I'm the head of research at DFINITY, and I'm delighted to walk you all through the agenda today. We have a number of exciting topics. First, some updates on growth, on the ICP roadmap, on a particular milestone named Coulomb and the Orbit public beta release. Then we have two updates on Motoko features. And finally, we have a community demo by DailyBid presented by Timo. So first of all, if you've been to the DFINITY office in the last couple of days, you may have noticed that it's super packed. It's hard to get a seating spot in the cafeteria. Radu, what's going on?
Thank you very much, Björn, and apologies for those that are having difficulties getting a seat in the cafeteria. So yeah, what is going on is that we're hosting a number of ecosystem teams, most specific Chain Fusion teams for the 7th edition of the ICP.Lab. So yeah, this actually is the end of the 3rd day. We still have one more day of packed cafeteria. So yeah, it's been quite exciting. As I was mentioning, we have lots of teams visiting us. We have had a packed schedule and like the teams kind of interacting with R&D teams from our side. We have had presentations from all of the ecosystem teams, kind of showcasing what they've built so far, what are their plans, and kind of how they are utilizing the Chain Fusion tech stack. We have had a number of roundtables around ledgers, around the cross-chain integrations, and around product security. So that has been exciting. And yeah, it still goes on. We still have one more day of packed schedule. And yeah, it's been exciting to see that in less than 2 years, in less than 3 years, the Chain Fusion ecosystem has grown to have so many mature teams that are going way beyond the ICP ecosystem, expanding into ecosystems like Bitcoin or Ethereum, and soon also into Solana. And it's also very good to see collaboration between the teams themselves and kind of very fruitful discussions between our R&D teams and the ecosystem teams. So yeah, a huge thank you to everyone that helped us put this together. A huge thank you to the R&D organization for this. And yeah, we still have one more day, and we actually have some technical deep dives tomorrow. So I invite everyone that is around the Zurich office to take part in ICP.Lab, and yeah, super excited about it. I think it's one of the best ICP labs that we have organized so far. Thanks.
Thank you, Radu, and I agree. It's great to have all these great builders around here at the DFINITY offices. That's really a great opportunity to build some great connections. Okay, thank you, Radu. Next up is Sam with an update on the ICP roadmap.
Hey, thanks, Björn. My name is Sam. I lead the engineering team at DFINITY, and we have seen last week Lara presented some feedback that we collected around this global R&D meetings. And in general, there was feedback that the technical details and depth is quite appreciated, but at times this comes at the risk that it's hard to see the forest for the trees. And so that's why we are experimenting with this new segment, which is sort of a bit a more high-level update on the roadmap and linking previous forum threads or discussions to our roadmap and milestones. So I picked a few highlights from this past first quarter. It's incredible. We are already at the end of the first quarter of 2025. It's not exhaustive. And let's please go to the next slide. You see, we have revamped or updated the roadmap. And I think by now, I would assume most of you here know, we have these 9 different themes. And within each theme, we have different milestones. And in this first quarter, we launched 5 milestones. I'll talk about them, and 2 of them we have a more detailed update later on in this global R&D presentation. I also want to give a bit of a heads up what's coming next. So these are these blue milestones. If you go to the roadmap, you see the QR code there. You will find many more that are probably rather happening later this year than the next sort of few months. And so let's start, look at the first theme, that is the compute platform, and please go to the next slide. So the compute platform is sort of the most core part of the roadmap. It's about extending the ICP protocol and making it ready for additional use cases to scale and to more demanding applications. And here I pick 2 highlights. One is this bounded weight canister calls. This is what's previously called best effort messaging, and it's an additional intercanister call class. So now you can decide whether you want to wait kind of indefinitely until you get your answer, or whether you kind of define a timeout and may get an unknown reply if this timeout is reached. This enables safe calls to untrusted canister. It facilitates that more calls can be processed more fairly if there is heavy load, and it enables you to build more responsive applications. So we had multiple presentations on the February Public R&D. Alin gave a demo of this, and I linked here the forum post that Ogi made of when this was first released. Then we also spoke about canister migration. There was a presentation by Martin and also a forum post. This is all part of the Flux milestone. The Flux milestone is all about providing additional mechanisms to balance load and increased compute capacity. The canister migration will allow developers to migrate the canister from one subnet that is potentially very loaded to another one. And it makes use of the snapshot mechanism to get a copy of a canister, upload it to a new subnet, and then there is going to be a second piece of this feature that is migrating the ID of the canister. So we spoke about this in February. There is lots of work happening on this, and it all goes to this Flux milestone that we expect in a few months. So that's the 2 highlights from the compute platform. Let's go to the next one. This is decentralized AI, or just AI in general. Here we have these 2 themes. On one hand, we talk about the self-writing internet or build with AI. And here, Caffeine is the big project that we work on and that is highly anticipated. We had multiple updates on Caffeine there was a hackathon in San Francisco. Jeff reported on what findings we had out of this hackathon. Martin told us that how we train the AI and how we make progress with refining existing models to produce better Motoko code. And then Manu recently updated us on some leadership changes and what we focus on in this Caffeine project. This will all culminate in the Vertex milestone that is also coming up soon. Then we have the other theme that is more under sovereign AI, or basically running AI services or models inference under the control of the IC. And here, I think the exciting news that was there and presented by Islam in February was this LLM canister. It basically allows you to use a canister interface to make calls to AI models. And for example, people have built chat bots with this. And there's various community projects that have started to build on this. These are the 2 highlights I wanted to pick out in the AI space. And since we have so many themes, I need to go quickly. So the next one, please, is next slide. Here, so that we don't just talk about DFINITY, I also wanted to make a huge call out to Odin.fun. This is a big community project, the runes trading platform. I think it's one of the really exciting projects that showed product market fit, that has impressive growth numbers and serves as a major advocate for the ICP technology or the chain fusion narrative in general towards the Bitcoin community. Then internally within DFINITY, we work on the Solana RPC canister that will become this Helium milestone. And similar to what we have already for Ethereum, there will be a canister API that will allow you to interact, read and write, and submit transactions to Solana, which is part of this DeFi singularity narrative, so that on ICP you can build DEXs or services that seamlessly allow you transact tokens from and to different chains that you are not even need to care on which chain they are. So that's the Solana RPC canister, part of the Helium milestone that will come up in the next few months. Then let's go on to the next one. This is privacy. Privacy, I mean, if is a key capability that is to some extent missing today, right? If you talk about ICP as a general purpose platform where you can build sovereign software, unless you can also keep your data secure or restrict who has access to it, the value is somewhat limited. And that's why privacy is such an important part. And the key milestone and the key work we do here right now is vet keys. And only last week, Christopher submitted this forum post, and we had a presentation also in Global R&D where the vet keys CDK was presented. This will all be part of this Niobium milestone, and I encourage developers to take a look because we are approaching also the release of vet keys in the coming months. So that's the big highlight in privacy. Let's go next to platform decentralization. Here we had early on in this quarter the solenoid milestone. This was about decentralizing the boundary nodes, and I think that was a major step, a major improvement in terms of decentralization. Next up there is now to also provide the logs and access metrics to the IC in a trustworthy fashion. So that's sort of the extension of the solenoid milestone. But of course, platform decentralization is a very broad topic, and ultimately the trust people have in ICP derives from the fact that users and developers are not at the mercy of the single entity. There is no single point of trust. And so that we can talk about all kinds of different aspects that need more or better decentralization. And one such topic was the network decentralization, no providers. For those people who spent time on the forum, there were quite some lively, if not very heated discussions on the forum in recent weeks. There was questions about independence of node providers, which triggered our team to propose some improvements in terms of node provider identification process, and also a means of stating that node providers are truly independent from other node providers. We plan to publish more proposals around data center security. This will keep us busy for the next weeks. I'm very convinced that this will lead to an improvement in terms of trust in ICP. And I invite the community and especially node providers to also participate and propose maybe solutions addressing the questions we raised. So that's the highlights from platform decentralization. Let's jump to digital assets. Digital assets, we are in Web3, where it's all about ownership, and users and organizations shall remain sovereign and stay in control of the digital assets, and so therefore wallets and ownership frameworks are common tools to view and manage digital assets. And that's what we focus on in this theme. Here we had the OISI version 1 release earlier this quarter. A lot of excitement around that. Since then, there were the sprinkles launch, which are creating incentive to regularly come back, do some transactions, and stick around. So go to OISI, make some transactions, don't miss out on your sprinkles. And today we will have Kepler talking about Orbit, which is another wallet, but also a framework that is more tailored to organizations where multiple people jointly want to manage custody of digital assets. So I don't talk too much about this because Kepler will tell us more about this palladial milestone. So then already time to go to the next one. That's governance and tokenomics. Here, this roadmap and all I'm talking about shows that ICP is evolving quickly. There is new services that evolve, and all of this needs governance, right? People need, and the community needs to decide, are we agreeing with this change or not? Should we go left or right? And that makes it necessary to have tooling, to have frameworks, to make decisions quickly. And of course, therefore, we all know we have the DAO, the NNS, And here I want to highlight one maybe a small change, but I think it's important, and that's why I repeat it, even though I guess it's the third time we mention it in global R&D. There was the introduction of this periodic confirmation, and so that forces people that want to receive their voting rewards to periodically either vote or confirm that they're still following the neurons that they follow. And this should incentivize a more active participation. So if you don't want to miss your voting rewards, make sure you periodically confirm you're following. Then you may have seen a series of improvements to the NNS tab, which is all around user experience to broaden and engage the user base. And this all will eventually lead to this neon milestone. The result should be a more active community, which is again an important ingredient for a decentralized platform. For example, there was the portfolio view that was introduced. Soon there will be changes on how you can configure your following. All of this again to improve and engage the community. Then I come to the last theme. Next slide, please. That's developer experience, and I hope developer experience leads little motivation. It goes without saying that unless you make it attractive and seamless for developers to build on ICP, you don't manage to attract developers. And that's a very important ingredient to have adoption and grow this platform and community. And we have various developer experience related activities ongoing. We plan a larger overhaul of the CLI toolkit, which is called DFX today. But for now, I focus on two updates. We had Jesse talk about dev docs and how we reorganize them, simplified. We constantly overhaul them. We want to make them more brief. We look at usage data and want to present topics that people seem to visit more often, more prominently, and separate sort of the background information and the theory behind stuff from the information that the developer really needs to build it. We are also working with a grant recipient who is rewriting a whole Motoko doc overhaul. That's underway. And then later today, we have Georgi talking about the Coulomb milestone, which is a whole lot of new features around Ninja. So I'm not talking much more about this. That's for Georgi to talk to us in a moment. And that brings me to the last slide, which is again this overview. I hope this helped to kind of put all these different topics a bit in context, how they relate to the milestones, how they relate to the roadmap. And you see there is a lot going on, and it's quite motivating to go through all these previous R&D presentations and see all the work we do. So a big thank you to our team. And I guess we'll now hear more about Poloidal and the Coulomb milestone. Back to you, Björn.
Wow, so much going on. Thank you very much, Sam, for this overview. And now you already made my segue to the next topic, which is Georgi. What's Coulomb?
Hey, Björn. And hi, everyone. My name is Georgi. I'm a director of engineering here at DFINITY. So yeah, I mean, Sam already mentioned there's something about ninjas there. And as you can see my image here, thank you, the designers from our design team. I really like it. Hopefully everybody else likes it. So thumbs up in the chat if you like it. Next slide, please. A bit of history. Who Monsieur Coulomb is. Pardon my French. That's what I understand, but that guy is really French. Amongst other things, he actually invented this contraption there, which is called torsion something, but honestly, I forgot the name. If you're really careful there on the image, the painting, you will see that he's actually holding this in his left hand. Really, what's the connection? You'll see it in a second, maybe with the next slide. Still not there, but let's talk about Coulomb physics. Well, I honestly don't understand this. Wikipedia helped me here, but if you look at the screenshots, bottom right, you will see this lovely number 6 point, and I'll leave it to you to read it. Plus it says quintillion electrons. And at that moment in time, I had this eureka moment, aha moment in life. And I said, wait a second, this reminds me of something. And this something is really cycles and teracycles and everything like that. And next slide. Now, how we are solving this problem? Well, a bit of developer experience here, really. I'm pretty sure you have all stumbled with cycles and some random number there that one needs to provide to run their kind of stuff. Well, I can tell you that that's in the past. If you're a first-time developer, you don't need to do that. If you're a second-time developer, second-day developer, yes, you still need to continue doing that. But let's talk later about that. For now, for first-time developers on ICP, they don't need to do that. Just go to ICP.Ninja and have some fun. And really, ICP Ninja is here to solve the first-time developer experience, at least at this moment in time. Gives you a really easy way to try things and get them up and running, get you up and running in seconds. As to what exactly we launched with this milestone, maybe on the next slide. So there are quite a few items here with quite some substantial impact. Don't be fooled by just the bullet points here, really boring. But if you look at the LLM chatbot example, for example, at the end, that's what Sam mentioned earlier. You can have your AI agents on chain. But also there are some cool features like accounts for ICP Ninja. Now you can save your projects. You can also share projects. You don't need an account for that, but an account will help you because you also have it saved forever. And really cool feature is exporting to GitHub your project and continuing there. You can always download your project so you're not stuck with ICP Ninja. And hey, in the future, I'm not going to review what we are going to do, but there'll be another batch of very cool features, so stay tuned. And just my next slide, which is also turns out to be the last one. Well, I mean, it says it all. You have the barcodes, please scan it. If you don't have your mobile device, ICP.Ninja, really that simple. And yes, .ninja is a top-level domain. And then the testimonials, don't focus on the how many stars there and how many views. That's not important. I just took a screenshot the moment it appeared. So yes, thank you very much for your attention and right. Thank you.
Thank you, Georgi. So if you're watching the live recording, the live show here, maybe go there after we finished. But if you're watching the recording, now is the perfect time to pause and scan this QR code. And I hope you're back in after trying it out. Anyway, if you're back now, welcome back. And we go right to the next topic, which is Kepler, giving us some insight on the colloidal milestone.
Awesome. Thanks, Björn. So yeah, I'm Kepler. I'm the team lead for the product enablement team. And today I'm excited to talk to you more about the colloidal milestone, which has landed about 3 weeks ago. And it's all about Orbit. And in a moment, we'll see how this connects to product enablement. If we go to the next slide, then a quick refresher on what Orbit actually provides us. So Orbit came as of a real world need that DFINITY had. So it started roughly a year back, and it came because we wanted to have a safe and secure finance operations. And we did look into this on the community. We look into what others were doing. We look into this, what other blockchains also were doing on this space. And we saw that actually we could tackle this in a very innovative way, that we could leverage the capabilities of the IC to provide a unique solution. And it quickly turned into us deciding to create an open source solution that not only DFINITY could leverage, but others could build upon and also use. And it could be used for not only managing digital assets or your ICP tokens and so on, but also your canisters or your smart contracts on chain. And Orbit kind of gives you this framework for representing your team on chain. So you can represent them with setting up the users, setting up the approval policy so that you can specify which users can request to do what and who are the people that are involved in approving those operations to take place. you can have this Orbit framework, or in this case, the Orbit station canister, then being the owner of the tokens or the canisters and actually enforcing those policies. And if you go to the next slide, we can see some of the ownership, the existing ownership model that we had on the IC. So if you are familiar with the certain frameworks that we have at the moment on the IC, we have the NNS, which overarching governance framework for the entire ICP community. And that makes a lot of sense for certain types of canisters. So if you have, for example, if you've seen the II canister or NNS DApp canister, which is more like a system canister at this point that everybody builds upon, it makes sense for the entire ICP community to have a say on what goes there. And that's why we kind of put them under the NNS community. Then if you are an individual team, maybe building your own project, then there's another framework, which is the SNS. And this is another governance model where you have a token for your own project, and then you have certain team members that want to participate in that project, getting involved in that SNS project. But if you don't fit any of those use cases, then at the moment as a small team, you really had mostly one choice. You had developers directly controlling either digital assets or canisters on chain. And this is what I try to represent here with these arrows from these two keys from these users directly into the canister. And what Orbit brings is now you can have this middleware layer where Orbit actually holds the business logic and holds the data. What are those users? What can they do? And then in Orbit, you can represent, for example, for doing a canister upgrade, maybe both developers can request for it, but then both also need to approve for it to take place. And then Orbit takes care of executing that. If you go to the next slide, then we can see how this can be powerful for treasury management. So at DFINITY, for example, we had this need to, for example, send grant payments and so on. And you can imagine that if a grantee gets approved, a member of the finance team will decide to send, for example, 100 ICP to John. And now with Orbit, what can happen is you don't need any more centralization at that point. You can actually have the entire org structure and who needs to be involved in approving those transactions represented in Orbit. So you can have that finance team member requesting to send those 100 ICP to John. And then, as you can see with that picture, 2 approvals are required. So in this case, it's 2 out of 3, which is enough. And then this actually gets then executed. So Orbit takes care of then sending the transaction, which helps to provide operational efficiency as well and captures with transparency all that has happened. So you also have like the audit log for all the transactions that have happened, who has approved, or why they have approved, or why they have not approved, and so on. And you capture all of that in Orbit. The other thing that provides you is within this feature, we also introduce an address book. So you can imagine that for organizations, we only want to send ICP or payments out if those addresses actually have been through KYC. So this address book is also leveraged for that. So you can attach tags or metadata into the addresses in that address book. And then you can configure the approval policy saying not only 2 people from finance need to approve, but also the address needs to be KYC'd. And then this Orbit policy system, which should be pretty flexible to support all of that, can then be used for those use cases. Another use case that I can remember here is we had some feedback of people saying, I have my accountant with the ledger and they can do transactions. So it's based on trust that I trust them not to actually move my assets. And now with Orbit, actually what they can do is as the owner of the asset, I can do as many transactions as I want, but then maybe I have my accountant and my accountant can request for doing the transaction, but I need to be involved to approve it for it to happen. And Orbit solved that problem. If you go to the next slide, this is how we also enable Orbit for to the part of, as I mentioned in the beginning, with product enablement. So you can not only use Orbit to hold digital assets, but you as being more like tokens. You can also use Orbit to hold actually canisters, so any calls to other canisters, which can be very powerful because now, instead of having a centralized model where an individual developer, for example, has access or individual canister has access to things, you can enforce now in orbit what are the conditions or the policies that need to take place for certain actions to happen. And this can be critical operations, such as changing the controllers of a canister, doing upgrades, or even uploading assets and approving them for asset canisters. And with these, we add two tools for developers to use. We have the Orbit Wallet, so that's the browser-based user interface that serves both to catalog, so you can add the list of canisters that you control, you can tag them, maybe it's helpful to have tags saying this is a production or a testing canister and so on. And with that, you can then have a more UI-based interface that you can interact upon and make certain operations. And then you also have DFX Orbit. That's our initial version of an interface that can connect to the orbit station that is useful for use cases where maybe you want to upload assets to the asset canister and then have, after that happens, the request sent to orbit for approval. Certain developers have already used this, for example, to integrate in their CI workflow so that when some PR is merged to main, then actually triggers that request, and then developers just receive a notification in the Orbit Wallet UI to then approve these operations to take place. And if you go to the next slide, then we can see what this Polluidal Milestone release includes. So it includes the orbit stations. So this is the main actual canisters that's owner control. So this is where you represent your team. And then you need to be able to find this. And the way that you find this is going through the control panel. So the control panel is more like this index, the entry point for you to access your orbit station. And it has on top of it this Orbit Wallet UI. So the UI connects to the control panel to find what are the canisters that are the orbit stations that your team has. And you can connect to this control panel either through the Orbit Wallet UI or through the FX Orbit. And it gives you, through this feature, also the following features. So we have the user management, we have these multi-approval policies. At the moment, we have native support on the UI for ICP, all the other ICRC1 tokens, so CK tokens and so on. Soon, we're also going to add support in the UI also for multi-chain assets. So you can imagine Orbit, because of the internet computer capabilities, being able to hold Ethereum or Bitcoin also natively there and enforcing these approval policies. You also have canister management with this release. This includes all of these operations for canisters, including monitoring. So you can configure also thresholds for monitoring there. And through the DFX Orbit, then all of these asset canister operations, which are a bit more complex, where you need to upload assets and so on. If you go to the next slide, then we can see some of the metrics for the last 3 weeks. We have roughly 25 teams onboarded using this system now. We had about 600 users registered and roughly 70 active users every week. These are some of the news articles where Orbit was mentioned. There was more also mentioned, yeah, but these are some that I am just trying to highlight here. And on the last slide, then I'm just urge you to just try. So yeah, if you're also watching this live, stay here, but afterwards then go and try out orbit.global. You have the QR code there. And yeah, just represent now your team on chain, and you should be able to represent most of the policies through the Orbit system. And whatever feedback you have, please reach out and yeah, welcome to receive them and upgrade and iterate on a better product for the community. And that's all for me.
Thank you very much, Kepler. And yeah, as an Orbit user myself, I really love what you and your team have been building over the last couple of months. It's really a great tool. If you haven't tried it, now is the right time to try it out. So thanks to everyone and to all the speakers in this session. We now go to the next part of today's Global R&D, which is the part on features, where today we have a hyper focus on Motoko. So Claudio, you have the honor to present two features for Motoko in a row: the base library and the update migration mechanism. The floor is yours.
So my name's Claudio. I'm from the Motoko team. I'm probably the oldest member now in many ways. Motoko's actually been around quite a few years now, and we've always made do with the existing standard library that we first came up with, but I think it's time for a change. For various reasons, we've had a huge effort, mostly spearheaded by Ryan Vandersmith, designing and implementing a replacement for the old base library. Probably shouldn't lurk too much, hover too much on that comic, but I hope it doesn't turn out to be true. Okay, so let's go to the next slide. Okay, so we want a new base library that is more familiar for both our users who are coming often from JavaScript or Python, but also for AI, because this is the AI age, unfortunately. So we want a library that's more familiar to use, more uniform. So, different containers should have the same or similar APIs. More useful, so we have more functionality and functionality that integrates well with the IC, and also more predictable. So when we first implemented our data structures, we chose to implement some data structures that have amortized good performance. But on the IC, that's not necessarily a good choice, because the IC places bounds on your computations, and you actually want to know that your operations will have worst case guaranteed performance. So one of the problems with the reason we're doing this is because our old library evolved over time. It really wasn't designed. So we've got inconsistencies in naming. We've got some APIs that are very impoverished, and some that are totally over the top because they were targeted at particular demos. And a lot of the data structures turn out to be awkward to persist. So Motoko has this built-in language feature for persisting actor fields or canister fields across upgrades. And the way we structured some of our libraries makes it very hard to just automatically persist them without doing a data transformation first. So we went back to the drawing board. We wanted to reuse as much as we could. So sometimes it's just a matter of removing a wrapper around an existing design. And then we wanted to discard libraries that were inappropriate. So often our hash-based libraries, because they have to resize their data structures every once in a while, are not offering worst-case performance guarantees, but average-case performance guarantees. And then there's also some libraries that have become popular in the community. So we wanted to integrate those into base. And we wanted to design everything so it just works with persistence in mind. So we've got both imperative and functional data structures. So imperative update in place efficient data structures, and functional data structures that operate on copies of previous values, so you can easily roll back to a previous state. All our data structures are persistent by default. Now, that means you can store them in stable variables. We've offered simplified type conversion, so you can convert between pure and impure versions of the same data structure, and also just between other basic types, especially iterators. We used to have a range function that was kind of unintuitive because it had an inclusive lower bound and an inclusive upper bound, which is not what programmers expect. So now we've added a range function, and we've added a range function to every type, every numeric type that makes sense. Motoko has two notions of arrays, immutable arrays, and all the operations on the arrays were in a single library, which caused naming clashes. So we've now separated that into two libraries, var array and array, which have a very similar API, but work on imperative and immutable arrays. And the other thing that was rather provisional in the old base library was the random module for dealing with random numbers. That's hard on the IC because the IC only gives you a finite supply of bits. So when you run out of bits, you have to order some more and wait for them to be delivered. So we've tried to hide that better and provide a more familiar API that programmers coming from Python or JavaScript will be comfortable with. And then we've lots of other small changes for consistency and convenience. So what we've got on the menu at the moment, so this is what's in, is this new library for imperative arrays, and we still have the old array library. We have a richer iterator library, so we've got operations like zip and stuff like that, which we didn't have before. We have a new array list library, which we've stolen from Timo Handke, a community member. And these are growable arrays or array lists that people from non-Java or C backgrounds tend to expect these days. And then we also have ordered maps and ordered sets. And the imperative versions are based on stable RB trees, so another library stolen from a community member, Byron Becker. These are all stolen with permission. So, and then we have just queues and stacks. And for functional programmers, so we'd like to encourage users to write functional code because it tends to be less error prone and more correct. We also provide the kind of list libraries from traditional for functional programming. So this is a singly linked list, different from the imperative list. Maybe we should rethink the naming. Then we have ordered maps and sets, which have kind of a functional API. So every operation returns a new map and a new set rather than modifying a set in place. And then we have a doubly ended queue. At the moment, it's amortized, but our new hire, Camille, who's just joined the team, has been implementing a non-amortized one that'll have worst case performance bounds. So here, just to give you a flavor of the API for our set library, that's fairly rich. I've just like listed all the operations, but obviously don't need that. So what's off the menu? So we've taken out data structures from the old library that either have better replacements. So this is the buffer class is now replaced by the imperative list class. And the reason the imperative list is better is that it doesn't have this performance cliff of dynamically growing, by some exponential factor over time. We've gotten rid of some of the experimental libraries from the early days that have been hanging around. So that's experimental stable memory and experimental cycles IMO and experimental internet-computer IMO. And some of them we've just decided to get rid of that annoying prefix experimental. And some of them we've just decided to throw away. So stable memory shouldn't really be using that directly. It's much better to use safer regions because they're isolated and different libraries can use regions independently without stepping on each other's feet. We've also gotten rid of all our hashing-based data structures. That doesn't mean we won't have some in the future, but the ones we have at the moment were either a bit odd or just have this performance cliff. When your hash table gets too big, you have to regrow and rehash, and that can take a long time and can interrupt the smooth operation of your canister methods. So obviously, replacing the standard library is a bit scary. But our intention is that the old base library will still be available for people who want to use it because they've got legacy code. But ideally, we'd like new users to start using the new library and provide a migration path. But we're still thinking about what that will be. Next slide, please. Oh yeah, finally, the random library was kind of, the old one was kind of awkward because every operation was partial because you might run out of entropy while you're sampling a value of some type. So every time you wanted a random number, you might actually just get failure, like, nope, there's not enough entropy, you better get me some more entropy and then I'll restart. And though it worked, it was kind of awkward and clunky. So we've designed a new API, which is much more natural for people to use. And it works both with cryptographic randomness from the IC and pseudo randomness using a PRNG. And so there's a simple example, which hopefully should be fairly familiar to users. Next slide, please. Okay, so here's some links. The QR codes will take me there. I just wanted to ask people for feedback because, we might be screwing up. And it'd be nice to know if people could maybe have a go at porting their code to use the new library, see what went well and what didn't go well. And I'd like to thank, in particular, the community members who've given us access to their code and support, like for testing. Okay, so everything's still under construction. We're still trying to decide what the migration path is, but please try it out anyway. So next topic. Okay, this is the new topic. So Motoko from the get-go has had this notion of safe upgrades and being able to incrementally extend your data and modify it as you upgrade your canister over time, your actor. So what does this look like? Next slide, please. So Okay, wrong slide. No, the slide's fine. So while that mechanism worked, it was also, truth be told, rather clunky. So what we wanted is a new, more flexible way to transform data during upgrades. So this is kind of the equivalent of schema evolution in databases. That is both simple, safe, fast, and modular. So you can separate your migration code from your production code. So for example, in the past, simple operations, even just like renaming some stable data field, some persistent data, would require like more than one upgrade, not just a single one. But now we've got a new feature which lets you declare an explicit migration function that is a transformation on the stable data of your old canister into the stable data of your new canister. And it can do a whole bunch of things in one step without requiring everything to be broken off down into separate little steps. So this means that persistent data can be, maybe consolidated. You want to merge two fields into one. Can decompose. You go the other way, take two fields and split them into, take one field and split into two. You might want to just rename a field or change the type and the representation of a field. Or you might want to just drop something, all in a single save. Why is everybody talking about legacy code? All right, next slide, please. So this is the old mechanism, Motoko, which still works and a lot of the time is perfectly fine. So in Motoko, if you declare an actor and you mark it with this persistent keyword, then all the declarations in the actor, all the fields, are implicitly persisted when you do an upgrade. So here we've got a little logging actor that maintains an imperative list of text values, and it has a single add function that is a one-way method that adds a message to the log. Okay, so it's a single log field list of messages, and maybe we want to extend this, upgrade this actor so it also records the time that the message was logged. So in Motoko, we could do that. We could just add another field containing another list, this time of integers, so the timestamps, and then we extend our add message to not only extend the log variable, but also the times variable. And the initializer of the times expression, basically maps default times to the existing log entries when you first do the upgrade. Now in Motoko, every actor actually has like its external interface, which are kind of the API it presents to the outside world, the candid. I'm not showing that here, but for the log actor, it's just a single method add. But it also has an internal interface that's used for doing upgrades. So the internal interface basically lists the names and types of all the actor fields that'll be persisted across the upgrade. So in this lower row, under each of these code fragments, you see that, well, the first actor just has a single log variable of type list of text, but the second actor has an additional log times variable of type list of int. Okay, and we use that type information to check the safety of upgrades. Next slide, please.
We're running a bit late, so if you could speed up.
Okay, yeah. So as well as adding fields, you can also remove fields in a single step. So those are the basic ingredients of what you can do. Now that all looks like very simple and very useful and safe, but it gets problematic. So next slide, please. So imagine you had this actor with the log and times variable, and you wanted to actually consolidate them into a single map, a single field. And here we decided, well, it's still the log, really. It's just, so let's keep the name log. So if you actually want to do this upgrade, so you go from this actor type on the left to the actor type on the right, you'd actually have to do it in 4 individual upgrades with the current Motoko, because you first have to add a temporary field that constructs the map from the previous 2 logs and times field. Then you can do another upgrade to drop the log and times field, then do another upgrade to add the log field, and then do another upgrade to drop the temp field, and then you're finally where you want to be. Okay, next slide, please. So to make this easier, we've added this new feature that you can basically take your actor that you want to upgrade to, and you decorate it with a function called a migration function. And the domain of this function has to be a record of stable variables, and the output is also a record of stable variables. And the idea is that the migration function will consume the stable variables of the appropriate types from the actor that you're upgrading, and then the values that it produces in its output record are going to be used as the initial values for any stable variables in the new actor. Okay, and this code gets run when you do an upgrade only. If you just do a fresh install of the actor, the code is not run at all, and you just initialize the actor fields as usual. So think of it as a bit of code that runs in between the upgrade, just to like massage everything into the right format so you can pick up where you left off. So now the actor actually has, has two interfaces. One is the pre-interface. This is kind of what is used to upgrade, what you're checking when you upgrade against the old actor, and then the post-upgrade interface, which is the actor that'll present, the interface that presents going forward in the future. Next slide, please. Okay, because it's really clunky to put that migration function inline in your code, you can also separate it out into a different library. And now your main actor code, the file on the bottom, just imports the library and adds the annotation, but the body of the actor is just production code, which means if you want to clean it up after you've done the migration, next slide, please, you can just delete the migration code. And now you're back to a basic actor that just looked like good old Motoko. Next slide. Okay, so these migration functions can be applied to all the actor fields if you want, but they can also be applied selectively. So if you have a huge actor and you only want to migrate like 2 of the fields, maybe consolidate them, you only have to mention those 2 fields in your migration function, and the other fields will just come along for free as usual. So you can be very selective, and hopefully this is not too invasive a technique. Oh, I thought I took that RTFM out. Okay, never mind. So this is supported in both classical enhanced orthogonal persistence, and you can also, even when migrating from classical to enhanced, you can apply a migration function. So it's all kind of nicely supported. We're still working on refining the checks that tell you whether you might be losing data. In some cases, we could be telling you more. But for now on, please, whenever DFX tells you, looks like you might be losing data, don't just click yes and ignore the warning, because you might actually lose data, okay? Anyway, that's it. I'm done. Sorry, I'm a bit over time.
Thank you very much, Claudio. So with this, we now, sorry, I have to jump over a few slides. With this, we now get to the last section. And for those who joined the ecosystem recently, which means in the last 5 years or so, and you haven't met Timo, let me tell you, Timo is a true DFINITY OG. He was one of the first to start working with Dom on DFINITY, the project back in the days, and the protocol that today evolved into ICP. And he has been working on several great kind of rethinking architectural things on the application layer in the last couple of years. And today, he's going to tell us about DailyBid. Timo, it's really great to have you here.
So I want to present DailyBid, the DEX with a fair price guarantee. I sometimes also call it a decentralized OTC desk. So what is it? What kind of DEX is it? First of all, it's an on-chain DEX. Backend is on-chain in a canister written in Motoko. Frontend, of course, is also hosted in a canister. And it's an order book DEX. So it is not an AMM. It's an order book DEX where you deposit your tokens and then place limit orders and wait for them to be executed. The order book is also hidden, meaning you cannot see other people's orders. Of course, the order book is present in the canister, but it's kept hidden intentionally, so that you have to place your limit orders only based on your own knowledge or expectation of the market. And most importantly, and that's also the thing that distinguishes it from other DEXs, that it performs so-called uniform price call auctions. So an auction, first of all, means that it's not a continuous exchange. If you place your order, and even if in the hidden order book it matches somebody else's order, it is not immediately executed, but the DEX waits until it's time for the next auction. They happen at a certain frequency, for example, daily, let's say every day at 12 p.m. noon UTC or so, and then all the orders get cleared. And then everyone gets executed at the same price. And these are sometimes called call auctions because there's this call period, which is the period between two auctions in which people place their orders, but they're not yet executed. In traditional finance, that's actually a known thing. You may be familiar with a diagram that looks like this. This is supposed to be the visualization of an order book. You probably know it from exchanges that you have used. The order book is usually visualized like this. You have the cumulative bids on one side and cumulative asks on the other side, which gives you two curves. Often they're step functions, not as smooth as shown here. And normally they don't intersect, because if they intersected, then there would be a trade happening immediately, a continuous exchange. But here in the call period, we allow this order book to build up, and the two curves can intersect. And when it's time for the auction to execute, the clearing algorithm looks at this and finds the intersection point and chooses that as the clearing price. And this clearing price has the property that it maximizes the trade volume that can be executed. So all the bids that are under the green curve on the right of the clearing price get executed, and all the asks under the red curve that are on the left from the clearing price get executed. These type of auctions have a number of interesting and desirable properties. The price is very fair. That is, for one, because we are concentrating liquidity, which would otherwise be distributed over the day into one single event. And also the hidden order book forces everyone to place their real limits based on their belief about, or their expectation about the market, not influenced by other limits from other people. It's very hard to manipulate the price because of these properties. Also, an advantage is because everyone gets the same price, it also means that your entire order, no matter how large, as long as it gets executed, is executed at the same price. So there's no slippage in your order. So these are properties that are shared with an OTC desk, and they're particularly interesting for people who have large orders. Finally, a small advantage is also that the reporting is very easy because you get a single price for your entire order and not many different prices, which happen when you put a market order and which then eats into the order book of a DEX. Okay, this QR code here is to a blog post, which you can read. And this QR code here is to a playground, which you can use to play around with the clearing algorithm. We also provide a Motoko package for this clearing algorithm. So now I want to switch to the demo. It is indeed. Okay, I hope you topped it up with enough, because with the compute allocation, it's probably burning fast. Okay, so here we go. I've just logged in. That's the interface. We see here a number of trading pairs. We see that the quote token is always USDT. All pairs are against USDT. We see here the last clearing price. In this test here, the auction clears every 2 minutes. So we see when the next one is happening. We also see a summary of the order book. As I said, the whole order book is private, of course, but we see a summary, highest bid, lowest ask, and the size of both sides of the order book. Now we see our tokens here in the wallet that's built in. My tokens shows all tokens for which I have non-zero balance. And these are all the tokens that can be deposited. Up here, we see the deposit addresses. This is an ICRC1 account, which can be used to deposit all the different tokens. Then we also have a native Bitcoin address. So you can deposit natively on the Bitcoin network here it gets converted to CKBTC without the user seeing that necessarily. And this is the ICP address from if you're depositing directly from an exchange. So let's do that. We copy this address. We are going to a wallet where we have some funds. So let's deposit some USDT to it. We paste the account, and let's say we deposit 2 USDT, go back to DailyBid, and then we can hover over this button, and we see that 2 USDT are available in our deposit account, and then we can claim them. So we intentionally left this as a manual process so that your balance doesn't change in the background without you doing an interaction. Of course, it could be made also in the background, but we liked it more explicit. We can also deposit with an allowance, and we're using the same deposit address for that. There's a deposit address which includes a sub account. We're using that as a spender for an allowance. So let me show that as well. I go here, the wallet, create an allowance for this spender that I've just copied. Let's say for 10 USDT, no expiration. This is the allowance that was created. And now we can go back to DailyBid and click here on deposit by allowance. Now we have to provide the source account where it comes from. So it's the default account that we have here, which is our wallet principal. We can paste it here, and we already see it says max available 2.66. So that's the smaller of the size of the allowance and the available balance in the source account. The front end has already pulled that for us. So let's say we want to pull 1 USDT from there. This should happen in the background, and then we can use these funds to place an order. So we can look at the ICP orders here. And let's say, put a little higher price. How much do we have available? Does the deposit by allowance come through? Yes, it has. Okay, so let's create this order. And maybe let's create another one at a different price and see if they really get both executed at the same price. When is the next clearing? It should be about to happen. Yeah, looks like both have already cleared. Let's look at the trade history. Yes, we see that both have executed at the same price. Then we can also withdraw from here, of course. Paste the destination account, can be any ICRC1 account. I think I don't have to show that. What I also want to show is if I go to a Bitcoin wallet and make a deposit, I'll do that in parallel. And we should be notified here about the incoming deposit. And of course, we can withdraw native Bitcoin as well. But since it goes through CKBTC, of course, we have to observe the minimum withdrawal size there, which is around almost $50. Eventually, of course, we want to make all assets that they can be deposited natively, like USDT on ETH, for example, and the user is not really exposed to the CK versions of them. But we've done that so far for Bitcoin, and we have also done it for T cycles. So the T cycles, for example, we can withdraw them natively. You can withdraw them directly to a canister, top up a canister from here. And you can also send cycles from a canister piggybacked on a message to the DailyBid backend, and you can top up your cycles like that. Okay, let's see and wait for the Bitcoin transaction to come in. Here we already see it. We see here 2,000 sats are pending. So it has picked up the non-confirmed transaction from the Bitcoin mempool already and shows it to us. And then slowly this will transition to when it's being available to be claimed in a little bit.
Timo, we are a bit late, so if you could.
That's what I wanted to show. And yes, in the future, of course, one can think that this may not be attractive for everyone if to have a daily auction. So I think we can divide the users into two groups. One is the people who have large orders, which are very happy to wait a day for the benefit of having no slippage, no front running, and having the fair price. And there are other users who have a small amount to exchange, maybe $10 worth to buy some token, which they need to try out something, and they don't want to wait, of course. And they are not so price sensitive. They're happy to be matched with the market maker, with the market maker, as long as they know they get the best market maker. And the goal for this is to turn this into a hybrid DEX. So when you place an order, you have an order mode. It's a checkbox. You can either go into immediate execution or you can go into the daily auction. And then the backend has to maintain two order books. The immediate one is included in the auction one, of course. It's a subset of that. And then we get the best of both worlds. And at the moment, we have only the daily auction with it running at a 2-minute interval during the alpha test phase. I hope you like it, and I hope you try it out as well. Thank you.
Thank you very much, Timo, for this exciting demo. So yeah, another thing to try out today. So if you don't remember, you need to try out ICP.ninja, you need to try orbit.global and alpha.dailybid. What was it? App?
DailyBid.com with dash.
Yes. Okay. So thank you again to all the presenters today. I think that was a really exciting program today. I hope you enjoyed it as much as I did. And with this, I'll let you go to your rest of the day or evening, wherever you're located. Thank you very much again for watching, and goodbye.